An example problem from the end of the chapter. So I'm going to do problem P20. You pull your little sister across a flat snowy field on a sled. Your sister plus the sled have a mass of 20 kilograms. The rope is at an angle of 35 degrees to the ground. You pull a distance of 50 meters with a force of 30 newtons. How much work do you do? So here's an image of that scenario, and we have been given information about the force, the distance, and the angle that is made relative to the ground. So that force that we have is going to be along the rope. The sled is going to slide along this direction 50 meters. And the angle is here at 35 degrees. So how do we solve this problem? Well, we know that the work that's done is equal to the force dot product with the distance. And we can alternatively write that formula as the magnitude of the force vector times the magnitude of the distance vector that's traveled times the cosine of the angle. And so we know that the magnitude of the force is 30 newtons. We know that the distance that's traveled is 50. And we know that the angle that's made between the force and the distance vectors, in this case delta r, is delta x. So we would just define that as vectors there's only motion along one direction, and so we call that delta x. And so we then have this dot product that's written as the magnitude of the force, the magnitude of the distance traveled. But since those don't align with one another parallel, only a certain amount of the force projects onto the distance vector that's traveled. And it's that projection or that shadow that we get from the dot product that tells us the magnitude of the work that's done. And if we calculate that work, we get 1230 joules.